Previously, we have looked at how we can draw the graph of parabolic functions, which are also known as quadratic functions. My name is Nanaya Wedu, and you can call me Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to continue to look at the graphs of parabolic function. So we are going to look at an example of how we can draw the graph of parabolic functions. Now let's look at this function. Now this is telling us that we should solve, right? Or by using graphical method, we should solve the simultaneous equation. We've been given a simultaneous equation where one is a quadratic and then one is a linear. So we have to use graphical method to be able to do that. Right, so let's look at how we can do that. So the question says that solve the graph of the function. So the first one is y is equal to x squared minus x minus 6. And then the second one is equal to y is equal to x plus 2. So we have these two graphs. So in this case, they didn't specify any values. So what we need to do is that we are going to draw a table and use our own specified values, right? I would always suggest that do not go beyond -4 and 4, right? So you are going to use from -4 to 4 for both of them to be able to do that. So you are going to have our table. So we can draw some table, right? So that we use the table to be able to find that. So we have our table here for the quadratic function, and let's draw a table for a linear function as well. So we can use this for a linear function, right? Okay, so we are going to have our x values. So in this case, we'll pick x values from -4, where we'll have -3, we'll have -2, we would have -1, we would have 0, we would have 1, and it means we have to go on to 2, to 3, and to 4. Right, so we'll probably extend the lines to be able to cater for all the numbers, right? So in this case, let's extend the line here. Okay. You could also extend the line here, and then the line here. Let's extend these lines as well so that we can have all of them. So you can as well be drawing your table using your jotter, right? Whilst we go through the process. So we have our 2, we have our 3, and then we also have our 4, right? In this case, we will have our y, which is equal to x squared minus x minus 6. So that is a y for this side, right? And then we also have the table where we have our x, right? And in this case, our y is equal to x plus 2. So we use the same interval. So -4, -3, -2, -1, 0, 1, 2, 3, and 4. So here you must use the calculator, right, to be able to determine the values one by one and be able to fill in. So we can assume that if our x is equal to -4, right, then for the quadratic, y will be equal to -4, in this case all squared, minus -4 minus 6. And we know that -4 squared gives us 16, right? So 16 minus -4 gives us +4, and then minus 6. That should give us 14. So we want to be as tidy as possible. So we are going to have 14 here. And then when we have x is equal to -4, for the linear, it is going to be what? -4 plus 2, right? Y will be equal to -4 plus 2. And that will give us -2. So we have -2 here. Now let's look at the next one. If x is equal to -3, for the quadratic, y will be equal to -3 all squared minus -3 minus 6. right? So we are going to have 9 plus 3, right? And then minus 6. And that gives us 6. So in the second one, we are going to have 6 here, right? And then when it's linear, x is equal to negative 3. We are going to have y to be equal to negative 3 plus 2. That gives us negative 1. So we have negative 1 here. So we'll move on to look at the next one when x is equal to negative 2. So we know that when x is equal to negative 2, for the quadratic, we have y to be equal to negative 2 all squared, which gives us 4 minus 2, right? Minus 6, right? So you are going to have 6 minus 6, which is a 0. So we have 0 here. And then in the case of the linear, if x is equal to negative 2, we are going to have y to be equal to negative 2 plus 2, right? And that also gives us 0. So this will also be 0. Then if x is equal to negative 1, right, we are going to have our y to be equal to negative 1 all squared minus negative 1 minus 6, right? So you are going to have 1 plus 1 minus 6, and that should give us negative 4. So you have negative 4 here. Mind you, all these workings that we do here is not as important as filling in the blank space, right? Using that to be able to fill in the blank space. So remember that the most important thing is to be able to fill in the value of x and the function y, right, for each of them. You can use a calculator to get them straightforward and be able to go through your process. So if x is equal to negative 1, then y will be equal to negative 1 plus 2, which in that case will give us 1, right? Then if x is equal to 0, in that case, all the x values will go to 0. So we'll have y to be equal to 0 all squared minus 0 minus 6. And that will equal to negative 6. So we have minus 6 here. Then if x is equal to 0, it means that y will be equal to, for the line, equal to 2, right? So 0 plus 2. So this will be 2. And then if x is equal to 1, we have our y to be equal to 1 squared minus 1 minus 6. So it means that y becomes equal to negative 6 as well. So here we have minus 6 here. And then for the linear, if x is equal to 1, we have our y to be equal to 1 plus 2, and that will give us 3. So we have 3 here. If x is equal to 2, for quadratic, we are going to have y to be equal to 2 squared minus 2 minus 6. So we have 4 minus 2 minus 6. And then we are going to have 2 minus 6, and that's going to give us negative 4 as well. So we have negative 4 here. And then if x is equal to 2, it means that our y will be equal to 2 plus 2, and that will be equal to 4. So we have 4 here. So we have 3 and 4. So if x is equal to 3, our y will be equal to 3 squared, right? Minus 3 minus 6. So 3 squared gives us 9. 9 minus 3 is going to give us 6. And then 6 minus 6 will go to 0 as well. So it means that we're going to have y to be equal to 0. And then in the case of x being equal to 3 for the linear, we are going to have y to be equal to 3 plus 2. And that is 5. So there's 5. Then finally, if x is equal to 4, we know that we are going to have our y to be equal to, right, we are going to have 4 all squared minus 4 minus 6. So in that case, you are going to have 16 minus 4 minus 6. And that gives us positive 6 in that case. So you have positive 6 here. And if x is equal to 4, it means that our y will be equal to 4 plus 2. And that will be equal to 6. So this side we have 6 here. So we've been able to fill for both of the functions, right? So we'll clean and then we'll draw our graph, right? This is rough work. This doesn't give us any marks. So as I said, you can use your calculator and then punch the values directly to be able to get your table. So we are going to use a table to draw the graph. Now before we draw the graph, let's consider our largest value for x and our largest value for y. That will determine how we are going to draw the graph. So for y, we see that we have 14, right? And then for x, we have 4. So between -4 and 4. So we are going to use our grid. So we'll pick our grid or our graph, and then we are going to draw our horizontal and our vertical line, right? So we'll move this a little bit so that we can draw our horizontal and vertical lines. So we are going to have a horizontal line here, right? Make sure normally you put it exactly on the line so that it becomes easier for you to draw. So let's use, right, then we are going to draw one here as well. You can as well decide to extend it a little bit so that it looks better. So we extend these ones, right? So we are going to look at probably how we are going to plot these points, right? So we are going to plot the points here. But before we do that, let's try the scale. So we are going to have on the x side, which is positive, we have 1, we have 2, we have 3, and then we have 4, right? Let's add 1 and then let's have 5. And then on the y side, because we have 14, we are going to use 2, right? We have 4, we have 6, we have 8, we would have 10, then we have 12, right? Because we have 14, we need to move this down a little bit. Then we have 14, right? So we'll use a ruler to extend the line here, right? So let's use the black. That's fine. And then we have negative x side where we have -1, -2, -3, right? -4, and then -5, right? So in this case, you see that we are using 2 centimeters to 1 unit on the x-axis, right? And then we are using 2 centimeters to 2 units on the y-axis. Once you are able to draw the intervals well, that represents your scale. So you scaled it already. So you have -2, we can have -4, we can have -6, we can have -8, right? So now let's plot our points. So we are going to consider our points here so that we plot them. So we have our points here. Let's plot the linear graph first. So we have -4, -2, -3, -1. So we are going to plot -4 on the x-axis, right? -2 on the y-axis, which is here, right? Let's use the green one so that it looks distinguishable. -4, -2, -3, and -1, which will be here, right? And then the next one will be -2 and 0, 1 and 1, right? So you have -2 and 0, -2 and 0 will be here, right? -2 and 0. And then we have 1 and 1, so 1 and then 1, which is here, right? And then we have the next one, right? So -4, -2, -3, -2, 0, -1 and 1, 0 and 2, right? Then we also have 1 and 3. So we have 0 and 2, 0 and 2. We have 1 and 3, right? We have 2 and 4, 3 and 5, 4 and 6, 2 and 4, 3 and 5, right? So this is not the 3. Let's correct it here. So 3 and 5. So this one I have to be very careful and take your time. If not, you'll not get the right thing. So 3 and 5, and then 4 and 6. Okay, that's right. So we see that for that graph, we get a linear. So we can put a line through the greens, and you see that you are getting a linear. It's passing through every point here, right? So we are passing through every point here. Okay, so we have a linear. Very good. Okay, so that is it. So basically touching all the points here, right? Touching all the points in the line form, right? Now let's plot the quadratic as well. So the quadratic has -4 and 14, -3 and 6. So we have -4 and then 14. So we begin from here. Let's use black so that it distinguishes the two of them. So -4 and 14 is here, right? And then we have -3 with 6, which is here. You need to ensure that the points are at the right place. And then we have -2 and 0, -1, -4. So we have -2 and 0, -2 and 0, right, which is here. -1 and -4, which is here. And then we have 0 and -6, 1 and -6. So we have 0 and -6, which is here. 0 and -6. And then 1 as well goes with -6 here. And then 2 goes with -4, right? And then 3, 0, 4, and 6. 2 goes with -4. 3 goes with 4, right? And then 4 goes with 6, right? 3 goes with 0, and then 4 goes with 6. You need to carefully look at them very well. So 3 goes with 0 instead. And then 4 goes with 6 here, right? So we see that also gives us a quadratic graph. So we can use a freehand. One thing that I learned is that you can seize your breath a little bit. It helps you to get it well. So I seize my breath. I got it well. Right, so this is a quadratic graph. So we can put the line, right? The line is y is equal to x plus 2. Then the quadratic graph is y is equal to x squared minus x minus 6. Now, we need to find the solution to this quadratic graph. So all that we are trying to do is that we want to, at the end of the day, right? So it moves here. Probably they didn't move it to this one. So yeah, so that is a quadratic graph. It has to move here because I moved it a little bit. So the solution to the quadratic graph is basically the point where the line touches the curve, right, on the x-axis. So here, the line touches the curve here as x equal to -2. So the solution to the graph will be x is equal to -2 as one of them. And then here too, it touches it as, right, the line touches the curve as x is equal to what? 4. So we see we get the two values, which are x is equal to -2 and x is equal to 4, right? So we can see that now we can use the graph to be able to determine the solution to, right, the graph, or we can determine the solution to a graph when you are given two different types of graph, the quadratic graph and the linear graph. So in this lesson, we have basically considered how we can find a solution to a graph. In this case, you have been given a quadratic graph and a linear graph. And we've seen that to be able to do that, we must be able to, in this case, they didn't give us a range of values. So we determine a range of values for ourselves, which are from -4 to 4. And then using those range of values, we've been able to draw the graph. And then we've determined the solution, which is where the linear graph touches the quadratic graph. So the points where they touch on the x-axis. In our next lesson, we want to look at another question on drawing graphs of parabolic functions. Remember to like this video, share this video, and subscribe to my YouTube channel. See you soon.